Well, hello and welcome, Math 1. Mr. Robinson back here with part 2 of the two-part series here with triangle, congruence, conjectures, and such. This one's going to be faster. Last one I did side, 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 and side, angle, side. This time I'm going to do angle, side, angle, and angle, angle, side. Reasons it's going to be faster is because, well, for one, I'm not really going to talk on this page really right here. This page is covered in the first video. If you want to look to it again, it's the first 10 minutes of that video that covers these terms here. If you know what they mean, you could skip it entirely anyway, but that's kind of up to you. I'm going to go straight to practice problems here, equivalent to what's going to be asked of you when you're doing the practice problems as well when you're on IXL. But these are, like I said, like the other ones, it should make a lot of sense. Just I want to note the big difference between angle, angle, side, and angle, side, angle, and it's this. In angle, angle, side, let me just draw two kind of quickie little triangles. Boom, boom. Okay. In angle, angle, let's start with angle, side, angle. In angle, side, angle, you have two sides that are congruent, or you have a pair of sides that are congruent, and then two different pairs of angles that are congruent like this. Now, the thing is, though, the side is in between those two angles that are congruent. This is angle, side, angle. Okay. In angle, angle, side, the side is outside of the two angles that are congruent that you know of. So it's going to be looking like this instead, right here. Now, our textbook, which we're not using right now, but our textbook doesn't talk about angle, angle, side until much later because they have you kind of prove that angle, side, angle can still be built through this using what's called the triangle third angle theorem. And we're not going to get into it, but it's this. If you know that two angles of a triangle, or two pairs of angles in a triangle are congruent like this, then the third pair has to be congruent to each other here and here, which gives you an angle, side, angle right there. So once you do the third angle, you know they're congruent. Okay. Now the reason for this is because you might have heard this or done this before. The interior angle sum of all triangles is not only a constant, but it's 180 degrees. So the angles in all triangles add to 180. That might be important someday. It will be pretty soon for you guys. If they add to 180 and this is 40 and this is 60, that means this is 80 and this is, like that. So you can understand that the third angles are congruent, so you can make angle, side, angle out of it. But anyway, the point is they're the same thing. They can give you the same information. You can find the same answers regardless, but with what you're given, is the side in between the angles or not, that'll make it one or the other. Okay, but like I said, if you saw the other video, you've seen two-column proofs and you've seen these properties. Let's jump right into it right now and get started. And kind of confusing drawing. I don't know why they give this part right here to make it all confusing, but a lot of stuff's already marked for us to help us for this one. We just got to make the final statement here. So it's given here that segment ST is congruent segment. I mean, look, I'm talking through this as if you want to learn this stuff someday, but these two marks are congruent right here. These two are known to be congruent. It's given that angle RUV is congruent to angle SUT. And then they say that these two parts are perpendicular. These segments are perpendicular, they make a right angle. These segments are perpendicular, they make a right angle. All right angles are congruent, therefore angle V is congruent to angle T. The one statement I want to make here is it's kind of interesting that they used a single letter for these. You often see three-letter angle designations like this. They used a single letter here because they could. There's no other possible angle that you could confuse angle V with right here. Whereas if I said angle U, what's angle U? Is it this? Is it this? Is it that? Is it this? Is it this? Is it the whole thing? There are a lot of other things that can confuse with angle U, but there's only one angle V, only one angle T. Anyway, this looks like a classic case of angle, angle, side with angle, angle, side right here because the side is outside of the angle right there. That makes it so. Okay. All right, moving on to the next one. More classic case of two triangles right here. We're going to mark some stuff up as we go. W is the midpoint of SU. Now it says W is the midpoint of SU. It does not say it's the midpoint of VT. So it's the midpoint of SU. That means that these two parts here are congruent. We do not know that these two parts here are congruent. We can't state that for any particular reason that we know of. We can state these two are, and that statement is built all the way down here from that first statement right there. Definition of midpoint makes that one true. Segment TU is perpendicular to segment SU, and segment SV is perpendicular to segment SU right there. All right angles are congruent is what they're going to state right there, so they made that marking. And finally, these two angles here, SWV and TW, are congruent right here. These are vertical angles. Vertical angles right there that mark those two congruent. Now these two triangles are congruent by angle, side, angle with angle, side, I say angle side angle with angle side angle. I mean, that's what it is. This is angle side angle because the side is in between the known sets of congruent angles, and we're done. And again, I could not have said these two were congruent right here because we do not know that W is the midpoint of those. I think at this point we now know, but we weren't given that. Okay, these markings here, these are not markings of congruence. These little arrows mean markings of parallelism. These sides are parallel, the opposite sides. Segment EF is parallel to segment HG. That's first one. And then these two are parallel, again, right here. This is where we have the diagonal. If you saw in the first video, this is where you're going to get a classic case of alternate interior angles. Now, you have two different sets of parallel lines cut by a transversal. Let's see how they build it first. Angle FEG is this one right here. That's congruent to angle EGH right here. We're going to put it right here again, alternate interior angles are congruent. Now, how do we know that? Because the parallel lines are these two right here that are cut by this transversal that makes those alternate interior angles. You can see it in blue. Ignore the purple. Look at only the blue. Those are your alternate interior angles. That means that the EF and HG one led us to this statement. Those parallel lines led us to this. These parallel lines are going to lead us to this one here. EGF is congruent to GEH right here. Those are alternate interior angles, a different set, differently, uniquely congruent. And then EG is congruent to itself by reflexive property because it's a shared side in both triangles. You have angle side angle with angle side angle right here, and that statement gives you that one right there. I think that was the only thing I'd fill out, but it's once again explaining it. Okay, next problem. Nothing's marked, so we're going to have to make the markings for ourselves. By the givens, angle H is congruent to angle G. Again, there's no way that we can confuse that with any other angle set. Angle HFI is said to be congruent with angle GFI right here. So again, another given. If they give it to us, then we can assume it to be true. And FI is congruent to itself by the reflexive property. That's the third statement there. And you can kind of draw that in by knowing that. This is not angle side angle because you can't skip an angle to state the next side right there. This is angle, then side. Angle, angle, side. With angle, angle, side right there is that statement. Again, we're only looking at angle, angle, side or angle, side, angle for these statements here. All right, kind of confusing looking drawn here, but let's fill some stuff in based on what we have. EG, segment EG, it's this long thing, is perpendicular segment EI. Perpendicularity means a right angle. I'm going to draw it in right now, right angle symbol. EG is perpendicular to GH, another right angle symbol right there. Guess we can say those are congruent, right? E is congruent to G. So these two statements help me lead to this one. And I think it's clear that we can start to state something based on that right now before we skip anything else. All right angles are congruent. All right angles are, here's the congruent symbol right here, are congruent. All right, the other congruent statements, GFH is congruent to EFI right here. That's a given statement. Again, those are not vertical angles, by the way. These are not vertical angles. These are not opposite rays right here. So it's just a given statement. And then EI is congruent to GH, also a given. It kind of looks like the first problem here, and we're looking at angle, angle, side right there. So that's angle, angle, side. Again, perpendicular. So this really helps to draw these things out or mark them somehow. I don't want to imagine them, right? They're going to be hard to imagine, so you might want to find a way to draw these things out best you can. I think we're kind of running near the end. We might have, let's look ahead. Two more problems here, right? Two more problems. Given statements, again, we got to mark this, and this is going to look a little confusing. I want you to know what the triangles we're talking about. Triangle FHK is this blue, let me use proper good markings. This green one right here, here's triangle FHK, all right? And then let's do another one here in blue. This is triangle FJG that are congruent, and I know I'm kind of overlapping that other one, so forgive me. Let's kind of like that. Those are the two triangles we're talking about, okay? Now, I talked about this in the previous video where we're, let's start to write this out. FH is congruent to FJ. That's the big guys right here. FH is the big green side here, and FJ is the big blue side right here. Hopefully that kind of makes sense that I'm marking up. It's not the little parts. H is congruent to J as far as angles go. These two right here, another given. Now right here they say angle F is congruent to itself. Well, of course, but that's because it's a shared angle in both triangles. See, in the blue triangle and the green triangle, it's a used angle in both. It's a shared one. That's the reflexive property in the works for angles. Reflexive property of congruence is not only for sides, it's also for angles, and that's an instance of it right there. So we are looking at an angle, side, angle right there. That's why these two triangles are congruent right here, and that's what we got. And I have one more problem to do with you guys here. Segment or line UW bisects angle VUX. So angle VUX is this guy right here. Segment UW or line UW bisects it. That means these two parts are congruent right here. It does not say that it bisects angle XWV, so I have no knowledge that these two parts here are congruent. I can't state that. And they don't either. But they do give us that angle V is congruent to angle X. So this part and this part are congruent. I'm going to mark these up before I do the problem this time, and let's see if we can build from it. I have no knowledge, again, these angles are congruent. Won't help me anyway. There's no angle congruence conjecture. I don't know these sides are. It's not a midpoint or anything, but this side is congruent to itself. It's a shared side. It's the reflexive property. UW is congruent to itself, and that's the one we're doing right here. That's the reflexive property of congruence, once again for sides instead of angles. And if you see above, VUW, angle VUW is congruent to angle WUX by the definition of angle bisector. That was the marking that we made from the bisector statement. This is another angle side with angle side right here. That's why those two triangles are congruent. It always helps to look at these statements again. Make sure that you understand the order in which they're written. The order does matter. They're not just alphabetical always. Maybe you start the first one alphabetically. The next one is about the parts that correspond. Make sure you pay attention to those for just down the line stuff. That was the last problem, so that'll do it for this, guys. Hopefully this was all helpful for you. You don't have to watch the whole thing, but if you did, hopefully you built on it. You'll have different looking problems, but see what you can do there. Take care.